In our last video, we have mentioned that the Earth will not be tidal locked before the Sun becomes a red giant star. What's the origin of the Sun, and what's the destiny of it? Today we are going to talk about stellar evolution. Initially, all stars are born from interstellar clouds, often called nebulae or molecular clouds. What is a nebula? Nebula is actually a mass of gas or dust scattered in the universe. This dust may have hydrogen or helium. Typical giant molecular clouds are roughly 100 light years across and contain up to 6 million solar masses. Then these substances will collapse due to the gravitational effect. As it collapses, a giant molecular cloud breaks into smaller pieces, and each fragment gradually aggregates more of gas and dust. Then its density and pressure will increase. According to conservation of an angular momentum, it may rotate during this process. Since the rotating speed is increasing, the temperature at the center point will rise. We call this hot rotating sphere of gas as protostar. Once the temperature of a protostar reaches a certain value, it may cause nuclear fusion, and a star is born. Further development is determined by its mass. We take the mass of a sun as a reference. This is 0 solar mass. This is 0.08 solar mass. And this is 0.5 solar mass. This is 8 solar mass. If this protostar is of relatively small mass, let's say it's less than 0.08 solar mass, its temperature is impossible to trigger nuclear fusion and fail to turn itself into a real star. This is called a brown dwarf. Once the hydrogen fusion is triggered, it will be the birthday of a star. The lifetime of a star depends on how long it takes for the hydrogen to burn in the central region of a star. Generally speaking, the greater the mass is, the faster the hydrogen burns and the shorter a star's life will be. If a protostar is greater than 0.08 solar mass but less than 0.5 solar mass, then it is called the red dwarf. The red dwarf looks in red due to its low mass and relatively slow hydrogen fusion. A typical example of red dwarf is our neighbor, Proxima Centauri, which is the closest star to the Sun, only 4.2 light years away. Although its brightness is low, it has a long life. Generally, a red dwarf can live 6 to 12 trillion years, and the life of Sun is only 10 billion years. For stars with mass between 0.5 to 8 solar mass, their light looks in yellow or yellow-white, so we call them yellow dwarfs. The Sun is one of them. If a star is even bigger, more than 8 solar mass, we find this kind of star is in blue with a short lifespan of merely 10 million years. One example is the Pistol star in Milky Way. This star owes its name to the shape of Pistol Nebula, which it illuminates. Now let's talk about the old age of stars. The reason that a star can shine stably is that its gravity and fusion effects are balanced. However, the star is constantly releasing energy. Its mass is also decreasing constantly. When it turns into old age, the gravity can no longer control the fusion. Its fusion will become more and more intense, and it will expand into a red giant. Our Sun will also become a red giant in later years and devours inner planets, including the Earth. So what should we do? A recent Chinese sci-fi movie, Wandering Earth, tells one of the story. When the Sun dies out, the people of Earth build giant thrusters to move the planet out of orbit and sail to a new star system. Some people argue that we should move to Mars if this actually happens, and that's exactly what Elon Musk and his SpaceX is trying to do now. But don't worry, the Sun has a total life of 10 billion years, and it is just 4 billion years old now. We still have 5.4 billion years to think about what we can do. Since the red giant is getting bigger and bigger, the density of the inner core and temperature will drop. Then the fusion recedes. After a period of time, the gravity will regain the upper hand. The star will shrink again and go into the last stage. When it shrinks, the outer layers are expelled as a planetary nebula and thrown into the universe, and its core collapses into a dense white dwarf. If you put the sun into a box as big as the Earth, then the density of the sun is almost the same as white dwarf. So you can imagine how big the density of the white dwarf. Then after a long time, a white dwarf have cooled sufficiently and it no longer emits significant heat or light, and the white dwarf will become a black dwarf. It is estimated that this stage may take hundreds of billions of years, which is longer than current age of the universe. So the black dwarf is a theoretical stellar remnant that cannot be found in the current universe. Since the mass is different, other stellar evolution are not exactly the same. For example, the red dwarf star will cross the red giant star stage and becomes a white dwarf star directly. And the blue star will experience a stage called a red supergiant. Red supergiants are similar to red giant, but with more masses and intense fusions. When the red supergiant is formed, the most outer fusion is hydrogen. The inner layer with a higher temperature it becomes a fusion of helium. Then the fusion of carbon, nitrogen, oxygen, all the way to iron. Because of iron is the final product of fusion. After a period time of fusion, gravity regains the upper hand and begins to shrink. So it will also eject other outer substances. But this eruption process is much more powerful than the red giant that we just talked about. It will include a so-called supernova. In Latin, nova means new, referring to what appears to be a temporary new bright star. Then its core will collapse into something denser than a white dwarf star, called neutron star. The extremely high pressure causes electrons and protons to fuse by electron capture. Then a planet composed of neutrons will be formed. If the mass of the blue star is even greater, it will become a more magical celestial body called black hole. This is the death of a star. So in the end, the fate of a star becomes a black dwarf, neutron star, or a black hole. In Marvel Comics, Thor's hammer is so heavy that no one else can lift it except Thor himself. Do you know why? Because it is said that the hammer is made in the heart of a dying star. What is a dying star? Now we understand that dying star is actually a white dwarf or a neutron star. The density of them is super large. So no matter which star is used as the material of Thor's hammer, it will be very heavy. Thanks for watching. What do you think human beings should do to survive when the sun becomes a red giant? Please leave a comment and let us know. We will see you next time.